Hi, and welcome to this episode of Ask STARBASE. I'm Dory, and today's question is, how do wireless chargers work? Before we can fully dive into this topic, we'll need some background on electromagnetic induction. Hans Christian Ørsted is considered to be the person who discovered electromagnetism. He conducted an experiment just over 200 years ago in 1820, where he passed an electric current through a wire, causing a nearby compass needle to move. Reversing the current caused the needle to move in the opposite direction. As he continued to explore this phenomenon, additional experiments supported the idea that electric current produces a circular magnetic field around it. About 11 years later, Michael Faraday took this idea and experimented with the relationship between magnetism and electricity. He connected a coil of wire to a liquid battery in order to generate a magnetic field, then passed this coil inside of another coil connected to a galvanometer, a device used to measure electric current, to determine that a moving electric field induces an electrical current. While various scientists continue to experiment with electricity, the next step in the move towards wireless charging came through Nikola Tesla. He took what Faraday learned about electromagnetism and found a way to develop what is now known as a magnetic resonant inductive coupling. Tesla would use alternating current to electrify a coil with a transmitter. This Tesla coil would then generate a high voltage electromagnetic field capable of inducing another one in nearby objects like light bulbs, as long as they are within a certain range. The electromagnetic fields would drop off over a distance, so these objects needed to be close to the source. Essentially, he could power devices wirelessly by generating these fields, which has led to what we are able to do now with wireless charging. Wireless charging started taking hold in the 1990s with electrical toothbrushes that could be charged inside of a base. Like the coils used by Tesla, the charger base was connected to alternating current, which would run through a metal coil inside the base to induce a charge in another coil within the toothbrush itself. The energy inside this receiver coil is converted into DC or direct current to store in the toothbrush's battery. Today, scientists and engineers are exploring multiple charging technologies to power or recharge a range of devices, from Internet of Things gadgets to electric cars. Currently, there are three main types of wireless charging: tightly coupled electromagnetic inductive charging, loosely coupled resonant inductive charging, and uncoupled charging. The first two options are fairly similar, with the big difference being that the loosely coupled charging can reach devices that are several centimeters away from the source, while the tightly coupled version requires fairly exact placement. They both rely on a time-varying electromagnetic field to induce a current in a closed wire loop. The copper coils create an oscillating magnetic field that can create a current in a receiver. Larger coils can provide more current and reach greater distances. Uncoupled charging is able to make use of a variety of electromagnetic waves, including radio frequency, or RF, infrared, or IR, and even ultrasound waves. This method sends out lower energy waves to provide trickle charging at a larger distance. The most popular type of wireless charging currently in use is known as Qi, or the Qi standard, which was developed by the Wireless Power Consortium. Qi is an example of tightly coupled charging, and it is compatible with mobile devices developed by Apple, Google, Samsung, and more. While this technology is able to recharge devices, it does have its limitations. For one, the exact position of the devices limits how much the user can do with it while it's charging. It may be easier for a person to just plug it in if they want to use their phone. To address this issue, the Air Fuel Alliance is investing more into electromagnetic resonant and RF technologies to provide users with charging and mobility at the same time. For example, they are building charging spots into public spaces like airports, hotels, and cafes, in addition to expanding to trains and furniture. You can actually order furniture online that comes with built-in wireless chargers. Technology companies like Osaya and Energous are also developing chargers that would work like wireless routers, using RF or Bluetooth signals to provide a trickle charge within a much larger range. There are also concerns about efficiency, as some reports indicate that these chargers use double the electricity needed for a wired charger. As it is less efficient, wireless charging also means waiting longer for your device to fully recharge. Researchers from organizations like Wytricity and the Oak Ridge National Laboratory are working on how to improve efficiency, specifically related to charging electric vehicles. In fact, Oak Ridge has demonstrated a system with 90% efficiency for charging electric vehicles in a controlled setting. While these results are promising, there's still plenty to learn. STEM explorers like you could end up contributing to a world where our devices charge on the go without the need for cables. Thank you for joining me for this episode of Ask Starbase. If you have a STEM question you would like answered, please email it to us at ask@starbase-ct.com or go to our website, www.starbase-ct.com, and scroll down to the flip grid to submit your question. Stay safe and be well. Bye!